Okay, this is how to do number 12 on page 140. This is kind of a long problem, probably the hardest one on the homework. So, as you read the problem, it describes the chemical reaction. So we're going to have SO2 plus H2S is going to form water vapor, or actually liquid water, and sulfur. All right, as we balance this, let's look at, so the sulfur's in multiple spots, so let's save that till the end. So we have 2 oxygens on the left, so I'll make 2 oxygens on the right. Now I have 4 hydrogens there, so to balance it, I'll put a 2 right there. And now I have a total of 3 sulfurs, giving me a 3 right there. Okay, so as we read the problem, I think it's helpful to write down the information. So the question is, what's the volume of each gas? So we're going to have to do 2 PV equals nRT problems. All right, so we need the volume of each gas. The pressure is going to be the same both times, so it's 0.961 atmospheres. The pressure is 0.961 atmospheres. The temperature is 22 Celsius, which if you convert, and you add 273, that's going to make it, 295 Kelvin for both. And then the R value, since we're using atmosphere, is going to be 0.0821. And so to complete this problem, we need moles. So in order to solve for the volume of each gas, we're going to need the moles of SO2 and we're going to need the moles of H2S. And what we're given is that we can make 4.5 times 10 to the 5th kilograms of sulfur. So what we're going to do is we're going to do some stoichiometry to figure out from that sulfur how many moles of H2S were needed, and then again, how many moles of SO2 are needed. So we'll have to do some stoichiometry as well as PV equals nRT. Now let's start with the stoichiometry. So if we have 4.5 times 10 to the 5th kilograms of sulfur, okay, we need to get rid of kilograms and turn it into grams. So there's 1,000 grams per kilogram. And then we're talking about sulfur, so the molar mass of sulfur is 32.07 grams, and that's 1 mole of sulfur. And then let's do SO2 first, since that's the first reactant I've written down. So based on the mole to mole ratio, when you make 3 moles of sulfur, it takes 1 mole of SO2. And again, we're only needing to go to moles. We don't need to go to grams because N is number of moles. So we're trying to get the moles in order to plug into PV equals nRT. Okay, so this is going to be 4.5 times 10 to the 5th times another 1,000 divided by 32.07 divided by 3. So it's a large number. 4, 6, 7, 7, 2, 6, 8. Let's get my commas in there. So it's 4 million moles of SO2. Let's just get the other stoichiometry done, and then we can do the PV equals nRT. So it's going to be virtually the same. We have 4.5 times 10 to the 5th kilograms of sulfur. Same setup. 1 kilogram is 1,000 grams. The molar mass hasn't changed. Still just sulfur. The only thing that's going to be different this time is we're going to have a coefficient of 2 on the top. So 2 moles of H2S is proportional to 3 moles of sulfur. So all of these numbers are going to be the same. So instead of retyping it, I'm just going to multiply my answer by 2 because it's twice as many moles. And so we're going to get 9,354,536. So 9 million moles of H2S. Okay, so now that we have moles, so this number right here is like 4.67 or 4.68 times 10 to the 6th. Let's use that for PV equals nRT. So PV equals nRT. Plugging our numbers in, the pressure is 0.961 atmospheres. The volume is what we're solving for. The moles is what we just calculated, so I'm going to use that rounded number of 4.68 times 10 to the 6th moles. R, 0.0821. Make sure you're using the correct R value. In this case, the atmospheres is going to cancel with the atmospheres. The mole will cancel with the mole. Once I plug in my Kelvin temperature of 295 Kelvin, the K will cancel with the K. All right, so to solve for the volume, we're going to multiply these three numbers on the right and divide it by 0.961. So 4.68 times 10 to the 6th times 0.0821 times 295 and divide it by 0.961. It comes out to let's see, that is actually, oh yeah, so it's 1179, let's see, 1179 47200. So putting my commas in there, if I put it in scientific notation, I can move the decimal back 1, 2, 3, 4, 5, 6, 7, 8 spots. So this would be 1.18 times 10 to the 8th liters. That's a large, large number. Liters of SO2. Okay. A quick way to get the other answer instead of doing the whole thing again. Remember, the only difference between the H2S and the SO2 is a 2-to-1 ratio. So the number of moles is going to be twice as many. Instead of doing the whole thing, we could literally just multiply this by 2, since we know that it's going to be twice as many moles, so twice as many liters. Everything else is the same. So if I just multiply 1.18 times 10 to the 6th times 2, it's going to come out to 2.36 times 10 to the 8th liters of H2S. And there you have it. This is a combination of stoichiometry and PV equals nRT.
You did times 10.